Hi everyone. My name is David Radcliffe. I work at Shopify. I'm a production engineer, which is our word for SRE. If you're not familiar with Shopify, we are a commerce platform. We power almost 400,000 merchants, and our teams build infrastructure systems for our platform, which spans multiple data centers and multiple clouds. My specific team has been building systems and automation for our data center. And so that's what I'm going to talk a little bit about today. So just to give you a little context, a little history, a few years back, we had a single colo deployment. We had just a few cabinets, dozens of servers. Everything was tracked in a spreadsheet, and that was if we were lucky. I'm sure some of you can understand this, and this is maybe where you are today. Bootstrapping new servers took many hours and many manual steps. It was really painful, and I even heard stories of passing around CD-ROMs in the data center to install OS. Not a happy time. And then let's fast forward a little bit. We have now multiple data centers, many cabinets, hundreds of servers. Spreadsheet was just not working at all, as you can imagine. And so we started using a tool built by Tumblr called Collins, and this was software built to track data centers and hardware in data centers. And this was much better. We had a clear picture of what we had, and it helped us with our bootstrapping was down to roughly 30 minutes per server. There were still a lot of manual steps, and we had trouble customizing Collins to really do exactly what we wanted. So it still was not totally working. So fast forward again. This year we have even more cabinets. We have thousands of servers. At this point, all of the previous solutions weren't really working, and automation was necessary. We couldn't keep doing things manually. We couldn't do anything one step at a time. We had to automate everything. And so we built a custom solution. So we set out with a few goals in mind. The first goal was we needed to keep track of all of our equipment. This is mostly servers, but we have multiple data centers, and so obviously we need to keep track of what was in what data center. So we have data centers, we have rooms, we have cages, we have racks and chassis, and then we also track all the network equipment, switches and routers, and then everything inside of a server that could be reused. So disks, NICs, memory, all of those components. And another goal we had is since we're running our own hardware, this means that we have to keep on top of the supply chain. This is important so that we have capacity to fulfill all the requests, keep everyone happy. So having an accurate view of that is important. And finally, we wanted to automate our provisioning pipeline. From receiving new shipments of equipment to provisioning servers for a specific role, and even decommissioning old hardware needed to be automated. So we built Genesis. Genesis is our central source of truth. It's a shared database that has the details of all our hardware. We can look at it any time, and we can see what we have running and where it is. And it's surrounded by a suite of tooling that some of it we built ourselves and some of it is from other people. And together it helps us with these goals. It was important to keep Genesis up to date, and so we needed to automate all of the data collection. And so we have an agent that runs on every server, and it collects all sorts of information. You probably can't read this, but this is just a bunch of information that, mostly hardware information that we collect on the server and we send back to Genesis. Mostly hardware, and then some about the context of what's running on the server at the OS level. Genesis runs in the cloud outside of any of our data centers, and this is important for later. So next goal we needed to fulfill was automation. So we're tracking everything, but we need to automate our pipeline now. And so most of automation is not directly actionable by Genesis because it's not in the data center. And so we have automation agents that run in each data center. And Genesis mostly acts as a queue. And these agents will talk to Genesis and find out if there's work to be done in that data center zone. And they will pick up a job and run the actions. So Genesis has this concept of remote actions. This could be like power cycling a server, could be turning on the light on the server, bootstrapping or decommissioning servers. This allowed us to move away from human actions and playbooks into scripted, repeatable, automated actions. The friendly UI in Genesis kind of gave us a simple abstraction so that we could do complicated data center tasks, and anyone on production engineering could do these things. So how does this work for bootstrapping? We already use Chef for configuration management. The same principles could be applied to any configuration management system, but we use Chef, and so we started using Server Spec and Test Kitchen to test our Chef recipes. This gave us more confidence in our recipes and make sure that they actually do what we think they're going to do. So this we have a CI pipeline for our cookbooks, but this is not quite enough still. So we created a tool called LineCook. What LineCook does is it basically just wraps Test Kitchen, and it runs the Test Kitchen suites, which these different suites match the roles we have in production. And at the end, it uses Packer to create an image from the system that we just built. So every time it runs, it goes from the base OS and it builds up this complete system using our same production cookbooks that we use on the servers. It takes a snapshot image and we store that artifact for use in the data centers. And as a bonus, we can then translate those images into cloud image formats, like an AMI, and we can use those in all our cloud areas as well. So every commit to our cookbooks triggers a new LineCook run, which results in a new image. If someone breaks the build, or more accurately, they break the bootstrap, we know right away, instead of days or weeks later finding out that, oh no, we can't bootstrap this role from scratch. This was really important because we were often found ourselves like bootstrapping a server that we hadn't bootstrapped in a while, and it may work in production, but from scratch it doesn't work at all. And that was very painful. And we don't have that problem anymore because every commit runs from scratch in CI, and we have confidence in this process now. The next, we built our own iPXE framework. We call it Zygote, and it boots an in-memory live image. And this system knows how to set up all the disks and install this image on the servers. So how do we fit this all together? So from Genesis, we create a new Bootstrap remote action. An agent in the data center picks up the job, tells Zygote that this specific server should be re-imaged. The agent then reboots the machine using IPMI. The server boots and Zygote answers the call. It knows that this server needs to be re-imaged, so it boots the in-memory live sys and configures the disks, and then installs the new image on the server. Then the server is rebooted, and this time it boots up into the real system. At this point, we're basically 99% done because we started with the image. So then we run Chef once more to catch up any changes that have happened since that image was baked. If we had just started with the OS, the first Chef run might have taken, 30 minutes, depending on what software needs to be installed and configured. But usually now this first run is about a minute or two at most. Throughout this process, each piece of this system communicates back to Genesis and report status, so we can see from the UI where we are in the process. And once this last run is complete, the bootstrap is complete, server is in use and ready to go. This whole process takes about 10 minutes, depending on which server role and how many disks it has to configure, etc. And we can do multiple bootstraps in parallel easily. This makes it very trivial to intake a whole new batch of servers. Sometimes we take a whole new rack all at once and plug them in, and no human interaction. They all register themselves, go through this process, and just appear as spares ready for us to pick a role and use them. Okay. Some takeaways from what we've learned. Testing our bootstraps and making a CI pipeline was a huge win, and really every piece that we moved from a human doing manual tasks into a computer doing automated tasks was really great for us. Even if you don't have bare metal servers, you can still apply these principles to tooling that you can build around processes, and it's totally worth it to invest in the tooling. We're planning on making Genesis and these tools we've written open source soon. If you want to talk more about any of this or get an early look at the code, come talk to me. Be happy to give you that and talk more about it. The Shopify booth out in the lobby there has a bunch of our SREs. We've got a bunch of topics that we're happy to talk about. If you want to talk about anything, come over. And then we've got an engineering blog, shopify.com/engineering, and our Twitter, ShopifyEng, where we talk about some of these things too. And that's all. Thanks.
Thank you very much, David. Next up, we have Tammy from Dropbox.
Hi everybody, my name's Tammy Butow, and today I'm here to talk about durability engineering, or death before data loss. You can find me on Twitter, Tammy Butow, and I'm an SRE manager at Dropbox. Oops.
So we fail all the time, right? So this is a good learning lesson. Sorry, Tammy. So we're going to try something slightly different here, as embarrassing as this is. But, hey, you know what? We live and learn, and we're going to try again real quick. So Google Slides, yay. Let me see what's that? Yeah.
It is images, yeah. Can we reload it? Oh, that's fine. I don't have notes. Oh, perfect. Cool. Yeah, sorry about that. So now we're back. Woo! Okay, cool. So, like I said, my name's Tammy Butow, and I'm here to talk about durability engineering. I'm an SRE manager at Dropbox. So, death before data loss. Where does this whole idea come from? It really just comes from the idea of death before decaf, which is pretty popular. You'll see a lot of like t-shirts, and if you Google it, there's stickers and everything. So I just hacked that image because I was like, to me, like protecting data is super important. Just like people love caffeine and they never want to have decaf. So I took it from there. Okay, a little bit more about me. I'm the SRE manager for Magic Pocket, also the databases team at Dropbox. I'm the co-founder of Girl Geek Academy, which aims to teach 1 million women technical skills by 2025, which is pretty exciting. We recently raised quite a lot of money from the Australian government, which has been very cool. And I'm Australian. I live in San Francisco. I love Go, infrastructure, databases, automation, metal, and punk rock. And talk to me about Dropbox, because we're definitely hiring lots of really cool teams to work on. We're doing very exciting things. So durability engineering. This is the discipline that is often the responsibility of SREs. And it's something that we're always thinking about. How do we continue to protect against data loss? So I wanted to share a little bit of a story about why I care so much about preventing data loss. And it actually comes from before I was really working with computers. When I was 13, I was starting to program, but I also had this job at a photo lab, which was really interesting because I was programming and playing with computers, building hardware, stuff like that at home for fun. But then my job was processing film with like chemicals and stuff like that. And what I had to do was take the little canister of film, sticky tape it with exactly 4 pieces of sticky tape, because you put one canister there, you sticky tape it onto this plastic sheet, you have to do both sides, and then you put it through this machine, and it processes it, and it comes out the other side, and they should be developed. And so I did this many, many times. My boss was always like, go faster, Tammy, process like 20 in a minute. It was really hard work, actually. And I thought, okay, this seems all right. Like, I just have to do this, and it comes out the other side, everything works great. Except one time, the plastic sheet came out, and there was no film on the end. Like, oh my gosh, where did the film go? And then I asked my boss, and he said, you've just ruined someone's precious memories. I was like, what? I was like this 13-year-old kid, and I was so like shocked. I'm like, really? You're joking? Like, we can just get them back out, right? He's like, no, they are stuck inside the machine, and they will never be retrieved. It's like, oh my gosh. And then he's like, okay, so on top of this, you actually have to tell this customer when they come in that you ruined their precious memories. I was like, wow. So I actually did have to do that. The woman walked in, and I told her, look, I'm really sorry. I tried to process your film. I only stuck 2 pieces of sticky tape on. I made a mistake. And instead of sticking 4 pieces on, and your film's destroyed. And she just started crying. And she's like, that's my baby photos, graduation photos, all of these photos. I'll never get them back again. And from that moment, it was such a big lesson for me. Yeah, and that was when it was just film. I was like, wow, okay, people, obviously photos are very important. People create them for a reason, and you never want to destroy them. And for me, that's why just protecting people's important documents, photos, anything that they ever create, it's very important to me. And I have many more stories if you want to hear more of those. So what is Magic Pocket? Magic Pocket is an immutable content addressable block storage system. We actually built it from scratch at Dropbox over the last few years. We used to use S3 for block storage, but we recently moved over, and now we use Magic Pocket, which is in all of our own data centers. There's multiple exabytes, 3+ geographic regions, and we have over 500 million users using Magic Pocket. This is our Magic Pocket SRE team, so super tiny little team. That's a big thing that you'll realize, like myself, John, Vlad, David, Stephen, and Scott. So a pretty little team doing a lot of work and protecting tons, like millions and millions of people's data. When we were creating Magic Pocket, we went through these phases. So we had build, validate, scale, and optimize. A lot of the time we talk about build and we talk about scale and optimize, but we don't spend so much time talking about validate. How do you actually know that your system works all the time? How do you know that it's correct all the time? How do you know you're never losing any data, even the tiniest bit of data? For us, this is about the power of 0. So this is all about being able to show that you have no data loss. Everything is always there. You're always protecting everything. It's that power of having a flat line graph. No data errors. While you're building the system, while you're migrating data to the system, while the system's growing and growing, because we migrated over 500 petabytes of data. So we're working towards this big day, which we called base jump, which was when we were going to actually migrate everything over from S3. So over 500 petabytes of data in under 6 months. We were doing 30 to 40 racks a day. Of course, we had things like supply chain issues, logistics issues, but we just kept having to work towards that big day. So how did we do it? How did we remain confident? A lot of it was this idea of the power of zero. We built a lot of tools and a lot of systems to make sure that we always would be able to show everybody that we were confident in our system, it was working, and it was really great. And we also actually had over 100 people in this project. You can imagine from many different teams because you're doing something really huge. We like this book called The Black Swan, which is all about the impact of the highly improbable things that will happen. For our system, we always said that our system should not be impacted by things like routine disk failure, not having backups, backups not working, backups not being tested. And I think this is something that people talk a lot about when they think about durability engineering, backups and the topic of backups. But for us, it's so much more than that. And even with backups, we go pretty extreme when we do our backups. So we have local backups, we have off-site backups, we have many backup services that we run. We actually have really cool tools for the databases team at Dropbox as well, which is our metadata. And for that, we have alerts for backups. We have a web UI, so we can see every single backup job that's running. We do short cycles. We do long cycles. We alert on backup lag. You can always see if anything's happening. And usually we never get any alerts for backups because they're always working quite well. But if anything happens that isn't good, then we do want to get alerted for it. We want to get a page and actually track it to make sure everything is okay. So that's become very important for us. And not only do we track that, yes, backups are running, they're always working, but of course we also do restores. And we track that too. Do the restores work? We make sure that everything's running really smoothly all the time. So with Magic Pocket, we said to ourselves, we never ever want to lose a file. We want to make sure that we do multi-site replication, and we use the Markov model for durability modeling. So multi-site replication for us, I should explain a little bit more about Magic Pocket. So Magic Pocket has multiple zones. There are 3 zones, East, West, and Central, and we replicate data to each of the zones. So that means we can do disaster recovery tests, things like doing a zone failover, stuff like that. So we can always be testing. And for me, I really, really love disaster recovery testing because it makes your system more resilient. If you're constantly pushing your system to fail, then you learn every time you do a disaster recovery test. And for us, we don't just keep doing the same disaster recovery tests all the time. We might decide, okay, we're going to run a zone failover. Now we're going to push it up and make it a little bit harder. And we're going to see, okay, if we stress test it, what else might break? Is there anything else that might have a problem? So that's what we're always trying to do across all of our services. So there are a few focus areas for Magic Pocket: isolation, protection, verification, and automation. Isolation for us is in many ways. Physical, logical, and operational are some key areas. So physical isolation is things like disk, machine, rack, row, power feed, cluster, data center, region, hardware vendor, hardware revisions, and offsite backups. You can just imagine, we do have multiple hardware vendors, multiple hardware revisions. A lot of the time, this is very good because it actually is physical isolation. And with logical isolation, we always remember that failures cascade, bugs propagate. You can imagine if you have so much hardware, obviously everyone's always seen things like firmware issues or things like that. You see one problem somewhere and you know you're probably going to see it somewhere else, just knowing that that's probably going to happen. So operational isolation is something that I'm really interested in, especially with Magic Pocket. I think we've done a really great job at it. And I've worked at several companies now, and I think it is really amazing. So what we do is we have very good tools. That's a big part of it. Access controls, and also a very good release process. So this is our release process down here. We'll do many, many weeks of testing whenever we're testing something new, we're building something, we want to try it out. Then we put it into staging, and then we leave it there for a while, for a week. And then we move it out to one zone, and we check how is everything going there, because we have the 3 zones, Central, East, and West. and then we move it over to zone 2 and 3 after a week there. So that works pretty good. And it isn't something where we're like, okay, let's ship it today everywhere, because that's probably not a good idea for block storage when you care so much about durability and you really want to make sure you never lose data. So we do have this. It's a few weeks, but it works really well, and I think that's great. Other things we do are we have some safeguards, we do a lot of recovery, we do testing. We always say that our biggest durability risk is us, so we add safety measures for ourselves. You can see down here, this is the life cycle for volume. So we have a complicated delete process, we delete on the storage node, and then we move volume to trash. And then we have this service that does trash inspection. So we're always checking everything because we have, our team is very paranoid. That's the best way to explain it. We don't trust anything that much. We always have services that we built to check that everything is working exactly like we want it to all the time. I think that's a really good practice to do. Verification isolation. So this is all about detection and testing. We just assume that we probably will mess up, so we prioritize failure detection. We want to know, is all data in this system 100% correct all of the time? So this is a diagram of Magic Pocket. You can see here we built a service called Pocket Watch, which is all about verifying exabytes of data. And you can read a lot more about this on our Dropbox blog. We have really long articles that go into detail. But you can see there I put up a little diagram where you can see the zones, west, east, and central. And then we do all the disaster recovery tests, failing over the zones, lots of different types of things we do there. And we also have many other services that we've built. So I've listed a few here. One is the cross-zone verifier, which is an application-level walker that verifies all data is in the storage system and in appropriate storage regions in each of the zones. Another is a storage watcher, which is a sampled black box check that retrieves puts after a minute, hour, day, and week. We also have a metadata scanner, verifying all data in the indexes on the correct storage nodes, and then a disk scrubber, verifying data on disk is readable and conforms to checksums. So this is just a few of the services that we've built for Magic Pocket. And the cool thing about this too is a lot of the time when we do things at Dropbox, we might build something for a specific team, and then other teams see it and they're like, that's really cool. I want to use that tool in my team as well for my service. So that's what we start to do too. Our SRE team might create something and then help other teams do it too. So we actually did that with the Magic Pocket team, then went and were embedded on the databases team, and actually started to help the databases team do even better work. And one of those big things was actually called Naru, which is a tool that we created for prescription and remediation and allows us to have a lot more safety. So now Naru, it was built in the Magic Pocket team, but it's used by basically every team across infrastructure in Dropbox. And another piece of this too is responsiveness. For automation isolation, we want to make sure that we are very responsive, because that time to response is your window of vulnerability. And then in terms of safety, I mentioned a little bit, but Naru allows us to actually safely remediate any type of thing that happens. And I'll just show you here some examples. So Naru is human authorized execution of scary tasks. That's what we like to call it. It was created by an SRE on our team, David Ma. And he actually has done a talk for SRECon in Dublin about this, so you can check out the video and see a lot more about Naru. But it allows us to do things like reboot servers, hardware replacements, reformat hard drives, which is really great. And we can safely automate all of these problems away. So you can hear more about what we're building. We've got a technical blog at Dropbox/tech, and then also on my own website, tammybutow.com/speaking. I've got lots of talks there. So yeah, durability engineering forever. Thank you.
All right. Next up, Joseph. We're going to try and make a little time up here. Come on up. Personal story of disaster averted. I don't have that today.
Hey, everybody. So you hear a lot of stories about burnout in SRE. How many of you guys have actually, gone through that, had burned out, or sort of heard that story? That's a scary percentage of the crowd. So this story is about how to avoid that a little bit. So that's next slide. Arrow. Okay, cool. So this is the dream. It's San Francisco. It's always sunny and nothing ever goes wrong. So I work at DroneDeploy. It's a small little startup that is growing hockey stick-wise, just like you'd think, right? So that means everything's beautiful, everything's going according to plan. Well, what happens when you do that is you grow the engineering team, and it's a lot easier to hire Python and JavaScript developers than it is to hire SREs, as I'm sure you well know. So what happens with that is just as like more and more of the team is really depending on the SRE team, and for example, in this case, the engineering team grew by 4x, and the ops team grew by none. So it's basically me and another person on the team. So this can be a problem, obviously. There was an open rec for SRE pretty well far in advance, like, almost a year ago at this point. And it was like, oh yeah, we'll get to that. And it's just fucking impossible to hire us. So hero mode, activate. We can do this. We're smart people. We can get this done. No problem. Well, that only works for so long before it becomes a problem. So that's what I had done personally. I had noticed that, basically we just weren't responsive enough. We weren't getting enough time. We weren't getting enough stuff done. So I would just work extra hours, basically catching up for all the things I didn't get to do during the day when I was helping developers unblock them. And what happened with that is my partner was not particularly happy about that. She's very, very understanding. I appreciate her so much, but even she has limits. So, yeah, that's the thing that could have gone really bad. Luckily, I noticed that this was happening, and I called out for help. How did I notice, though, is the password to log into your computer, maybe type it in like 10, 20 times a day. Well, I came in one morning, and after a particularly long night, and I forgot the password that I'd entered into my computer 20 times a day for the last year. I knew half the characters. So this is something wrong. This is like disk failure, and you need to do something about that. So clearly something needed to change. So this is me a little bit ago, and I call out for help. Now, this is kind of a scary moment because, especially if you're in hero mode, you sort of realize hey, I can do this, but realize, okay, maybe I can't do it. Maybe I'm going to be judged to be okay, he's just a crappy engineer. He just can't do it, right? So let's get rid of him and get somebody else. Well, that's not what happened, actually. And this is the good part of the story. Actually, right away, within 5 minutes, I had my manager and the VP of engineering being hey, let's do something about this. Let's get people hired. We had this open rec, but let's make this happen. And that was really relieving for me because I thought that okay, I'm going to have a problem trying to level up in the organization. I'm not going to go as far. This is I just couldn't hack it kind of thing. And that's not at all what the response was. That's the real Slack messages. So what happened is everybody on the whole team, all of engineering, not even people remotely related to front-end engineers, back-end engineers, they all just were hey, we have to get some more DevOps engineers here, some more SREs. And luckily, we actually, as of Friday, just signed another person for the team, just accepted. And the moral of the story is, if you're feeling it, if you're feeling the burn, then you should reach out for help because people will actually listen. You don't have to you don't have to be I'm going to solve this all by myself, because that was what I tried to do. I even tried to just go do all the hiring on myself too, and that just caused more problems. So that's it. Ask for help if you need it. Don't just let it happen.
And next up we have Igor from Microsoft.
Do I move forward backward? I don't have a mic. Okay. All right. Why do SRE teams fail? Well, let's suppose we have the service team and we have an ops team and a dev team working for this. And we heard about how awesome SREs are, and we want to get SRE into our organization. What do? First of all, of course, we try to hire people. It's not going to happen. Hiring people is actually pretty hard, and pretty much you know about this. So what to do here? All right, we have kind of this ops team, which is pretty great actually, and SRE is kind of related to it. Let's just rename the ops team. It's going to work once we have an SRE team. New SRE is going to come in, right? Not quite. Basically, real good SRE candidates are going to smell this, and your reputation is going to go down. So how can we get more engineering into our SRE team then? Well, let's try then to get some of the developers, move them over to the ops team. They're going to love it and leave the company. Let's talk about teams. All right. SRE and SWE teams, as you know, I have traditionally kind of different goals. The ones they want to push shiny, happy features to production, while the other ones they want actually to protect production. They want to make sure your service is stable, reliable, and so on. So sometimes this kind of conflicts a little bit and leads to clashes between the teams. Sometimes they don't even speak the same language. While the ones are talking about metrics and telemetry and data-driven whatsoever, the others are asking, what, you want more logging? No, you don't want to. And then you have actually this Jane. Jane is a pretty awesome engineer. And everyone loves Jane because Jane is a genius. She has everything in her head. She knows everything in every system. And when there's a problem, you call Jane. Jane is going to jump in and say, sure, I'll fix it. Sure enough, it's fixed. The problem is Jane is not sharing anything with anyone. And after a while, if Jane leaves, there goes your knowledge. So let's talk a little bit about moving the needle. What does it mean to have real goals? Sometimes you feel like your team is actually working very hard and very long hours, and you're not achieving anything. It feels like you're digging a bunch of holes everywhere looking for gold, and you don't even know if it's gold down there because you don't have the right data. Getting the data is expensive, sometimes so expensive that you get trapped into not having very well-defined goals. Let me give you an example. Sometimes in our virtual company, our deployment system sucks. Let's take, I don't know, a week or something like this to deploy. And we know we need to fix this. So let's create this task, fix deployment. It's not going to help. It actually sounds great on paper, but once it gets assigned to an engineer, the engineer will not know when he'll be done. You just continue to work on this and crank on this forever. And then we have the problem with incentives. Incentives are actually not a problem. They're an excellent tool to drive changes and goals. And the major goal of a company is to make money. And of course, we have the sales guys talking to the executives saying, yes, if we only would have more features, we would be able to sell more. Selling more means more money. We're more successful. So let's align all the incentives for everyone in the company to give us features. And if you ask for features, all you get is features. At the IC level, what you see then are suddenly engineers bragging about how many features they pushed out this milestone. The first one coming in saying 30 features, the next one 35. And then there's this person coming in bragging about his 50 features on everyone's faces. And sure enough, most of these features actually worked, which is great. And it just brought production down 4 times last month. Isn't that great? No, because failure is not an option. We don't need someone to fail. We must prevent these people, all of them, from pushing their crap to production. What do? We have this awesome tool called process. So we kill by process. So let's think about it. ITIL gives us a lot of example of stuff that you should be doing. Let's take the daily cab. For 1 hour every day, we all sit grumpy in a cab meeting discussing about stuff. Or, even better, okay, so let's do this. For every single feature, we're going to get this risk assessment meeting every day. Or even much better. Let's then rubber stamp every single deployment that's going out. But not just rubber stamp, having everyone in the company rubber stamping it. Engineers, managers, executives, sales, everyone. So we're sharing the pain. Deploying now is equally painful for everyone in the company. And before we realize, we're living this toxic environment. Everyone is pointing fingers. Just trying to fly under the radar. So it's kind of not really optimal. Let's go back a little bit to the pig. So hiring is still difficult. But again, you have these awesome engineers in your team. Why not develop these engineers? Maybe pair them up with the SWE team. Get someone on the SWE team to understand system engineering. By the way, Cesar, a colleague of mine, is giving a talk about this exact topic tomorrow. Then we need to embrace this one-team paradigm. We want to make sure that we're working with one goal as one team. We want production to be successful. We want our customers to be successful using our product. Yes, there are differences. We have engineers focus on core features, engineers focus on site reliability, but at the end, we have the same goal. And Janes, well, pretty much everybody here has been a Jane for a while. I've been a Jane for a few years. And this kind of sucks because I did not have any vacation or weekends. I got called all the time. So let's share this knowledge. Let's prevent silos from happening. And about the goals, let's get data-driven. Let's make sure that we get all the data and the metrics before we try to create a task. Going back to the example, instead of saying fixed deployment, we take some better approach like reduce the number of manual steps during the deployment process from 15 to 10. Now you have something that you can measure. Now you have something that defines when it will be done. And fair enough, align your incentives to your team goals, not to the company goals. There are so many abstraction layers in between. You're going to get lost on this one if you do this. And more importantly, the cultural piece. Failure is not an option, is not really right. Basically, sometimes we need to fail, and we actually want to fail and learn from our failures. We want to make sure that we begin to grow, to take calculated risks. We want to push the boundaries. That's what we called this growth mindset. Thank you very much. My name is Igor. I work for Microsoft. And by the way, if you want to win a service book, please go to our booth where we have this. We're giving away one tomorrow. Thank you very much.
Okay, it's on now. Great. Last for today is Joel. Come on up. We're talking about certificates.
Hey everyone, I'm Joel. I'm a production engineer at Facebook, and I'm here today to talk to you about issuing certificates at large scale. At Facebook, we use X509 certificates for a lot of things. We use them for authentication. We have user authentication, service authentication, even host authentication. Specifically, we use X509 certificates. There's a lot that you can do with X509 just with the base model, but it also allows you to embed arbitrary data, which gets to be very, very useful as soon as you need to do anything special. There's alternatives for users. We can use passwords. Those always work fine, no trouble. We also have SSH keys, which I'm sure everybody has tried to manage before, and they love them. For services, we have pre-shared keys, which never ever need to be rotated or never get hard-coded. We also have Kerberos, and has anyone ever tried to do that and loved it? Okay, so we have one. I'm sorry. There is a better way. Even if you love Kerberos, there is a better way. You just need a few things before you start. First is security, because you're going to be creating literally the keys to your kingdom. You need to be able to secure your certificate issuance infrastructure. You're going to eventually find that someone's going to try to gain access to it who's not authorized. You should have your own certificate authority. Always create your own certificate authority unless you actually need third-party products or people that you don't control to validate your certificates. Ideally, of course, you would use an intermediate CA, not just a regular one. Fortunately, it's very easy to create a CA. 2 commands. Once you have that, you need some kind of a trusted distribution mechanism. You can do a few things here. You can provision certificates on hosts when they're initially provisioned. You've built your base image, and they include certificates. When a user logs in, you can use Kerberos, and you can fetch a token and issue certificates based on that. And if you already have certs, well, you can just issue new ones based on existing valid certs. And finally, you need logging, a little more logging, and then some more logging because you still don't have enough. You need to know absolutely everything that's going on with those certs, where they were issued, how many are being issued to a particular host. Because, like I said, these are going to become the keys to your kingdom, so you want to know what's being done with them. And when you do anything at scale, there's some challenges. One of them is the number of certs that you're going to issue. Here at Facebook, we have a couple. This graph is over 14 days and references an average of 1,000 per minute. You can see some peaks there where you have a bunch of new components that are requesting new certificates, but on average, it's 1,000 or so a minute. Every time you request a certificate, your CA needs to do a couple of things. Who wants the cert? What do you want to do with it? Are you even allowed to ask for the certificate you're asking for? How long can I, as the certificate authority, give you this certificate? And what extra information should the cert contain? There's a few things that you might ask for that give you some extra access. An interesting thing about our CA at Facebook is that it's completely automated. There's no human intervention through the whole process. Whether you're asking for a user certificate, service, host, anything, it's completely automated right up until the time it gets issued to you. And so, as has been asked many times in the past, who guards the guardians? Who makes sure that it's doing its job correctly and it hasn't been compromised? Every request needs a few things. You need to log absolutely everything. Where it went. You get a few benefits when you do this, though. You get authentication of both sides of a connection, mutual auth. You have authorization based on any attribute in the cert. You have accounting because you have all these layers of logging. And you get stateless authorization, no round trips to Kerberos. So let's run through a quick real-world example. You have a user who wants to access Facebook. Oh, all right. Well. So really quick real-world example then. A user wants to access Facebook, which I hear is a thing that people do these days. So you enter a username and a password in your browser, and you authenticate. Your browser authenticates that Facebook has given you the correct certificate for the server, and Facebook verifies that you've given it the right credentials for the account you're trying to access. But Facebook.com does not validate your browser, so you have single authentication in this case. We show you some things. Things are in databases. At the web server level now, the web server contacts the database, but it uses a client certificate when it opens that connection, which allows the database server to authenticate the client and verify its permissions, but it also allows the web server to authenticate the server and verify that it is actually indeed a database server that it's talking to and that it's the correct server. And that's mutual authentication. You don't need to be Facebook. You can benefit by having X509 at any scale because you can get rid of hard-coded credentials. You also have, by the way, 802.1x if you want to do that with your user certs and your VPN. Some final tips. Be serious about protecting your CA. Have a process to rotate your CA when you need to because something will happen. Use unique serial numbers, again, logging. and be very aggressive now that you have this shiny new thing about eliminating usernames and passwords in your code. Now that I'm only a little bit over time, thank you.